Hello, in this video I will introduce the average rate of change and explain how to find the average rate of change when given pieces of information. So average rate of change in calculus. So how do you find the average rate of change in calculus? So by now you should know all the derivative rules, and now we are going to apply it in real world problems. So yeah, average rate of change is nothing more than a slope formula. The average rate of change finds how fast a function is changing with respect to something else changing. It is the process of the calculating the rate at which the output changes compared to its input. So you could think of it as the average rate of change is, so we said it's the slope of a secant line. So when you're dealing with average rate of change, the big clue is you're gonna most likely need 2 points, 2 coordinates, because you need to find the slope. And in order to find the slope, you need 2 points, right? So average rate of change is delta y over delta x equals y2 minus y1 over x2 minus x1. Average rate of change, yeah. So average rate of change is the slope of the secant line. So here we have a curve, right? And if you recall, secant, it goes through the curve 2 points, right? Tangent only goes once. So the clue is secant goes through the graph twice, or it touches it twice. And you can use this formula f of b minus f of a all over b minus a. I think we will use this formula as well. So go ahead and copy this down. So you just have, yes, in order to do the average rate of change, you need at least 2 points because it is a secant, the slope of secant, right? So I'm going to say this again. Average rate of change is the slope of secant, and secant requires 2 points. So yeah, because we're going to go learn about instantaneous rate of change, and that's slightly different. But right now it's average rate of change. So let's do an example one. So example one says the population in Wyoming was 480,893 in 2000, and it looks like it grew to 547,637 in 2010. What was the average rate of change of the population over this 10-year period? So they don't give us 2 points, right? Well, if you want, you can draw like a little graph, graph. And maybe I think we should label, so yes, we should figure out what our variable is. So our x would be, I think it's most appropriate to use year. And then y could be like the population, right? So if you kind of like drew it, should be something like this. So x is the year, so in 2000, and then this is 2010, and then population is like 480,93, and the other one is like 547,637. If you kind of like plot it, it would look something like this. Not exactly, you get the point. So how do we find the average rate of change? So like we said, they don't give us 2 coordinates, but we can find 2 coordinates, right? If x is the amount of years and y is the population, we have 2 points already. So the population was 489 in the year 2000. So that's a coordinate. So I guess our first coordinate can be 2000 because our x coordinate is the year and the population was 480,893. 480,893. And what do you think our next coordinate would be? So our next coordinate states it was 547,637 in the year 2010. So 2010, there was 547,637. So average rate of change. So we could just use the slope formulas, right? So average rate of change x1, y1, x2, y2. So it's like, what is the slope formula? It's y2 minus y1 over x2 minus x1, right? So our y2 is, it's good to label it because you can get like lost track. So y2 is 547,637 minus y1, which is 480,893, all over x2, which is 2010, minus x1, which is 2000. Okay, so when you do it on the top, you're left with 66744, and then on the bottom, 2010 minus 2000 is 10. That is 6674.4, and then it's going to be people over year, right? Because on the top, it was a change of y, which is population. And then on the bottom was a change of x, which was year. So average rate of change looks like it was growing at this amount of people per year. Okay, so that was example one. Let's move on to example two. So in example two, they give us a table. So given the table below, find the average rate of change over each specified interval. Okay. Oh, and then the interval is 2 to 6. So how would we find the average rate of change from 2 to 6? Now this one you cannot use a slope formula. Did you know that 2 to 6 are both like x, they're both x values. So yeah, this is like your A, this is your B. So don't get confused. 6 is not a y value, it's not a coordinate. These are both x's. So you could use the slope formula. You could also use this formula, f of b minus f of a all over b minus a, right? So a value is 2 and our b value is 6. So I think we could do the bottom, right? So b minus a, so 6 minus 2. And then what's f of b? So just write it out. We'll figure that out later. So f of 6, right? Because our b value is 6, minus f of a. And then what on the bottom, what's 6 minus 2? 4. And then what's f of 6? F of 6 spits out, if you look at our table, f of 6 spits out a 23. And then what is f of 2? If you look at our table, f of 2 spits out 12. Okay, so 23 minus 12 is 11, and then 6 minus 2 is 4. Okay, so your average rate of change is 11 over 4. Okay, let's move on to example 3. So example 3 says calculate the average rate of change of f of x equals x cubed minus x on the intervals 2 to 4. So what is the difference between example 3 and example 2? This time they do not give you a table, right? They gave, in example 2, they gave you a table. This time they give you a function, f of x equals x cubed minus x, on the intervals 2 to 4. So 2 is, this 4 is not a y value, they're both x's, or you could think of this 2 as an a, and then this 4 as a b, right? So, and they give us this function, right? So what we're going to do is use the formula f of b minus f of a all over b minus a. So I think the bottom is easy because we said that a is 2 and b is 4. So that would be 4 minus 2, and then 4 minus 2 is 2. And then f of b, so f of 4 minus f of 2. So we kind of have to do some algebra to find f of 4 and f of 2, right? But we do have our f of f of x function, so that's good. Let's find f of 4. You just got to plug in where we see an x, plug in 4. So this would be 4 to the third minus 4. And that spits out exactly 60. And then let's just find f of 2 real quick. So this would be 2 to the third minus 2. So 2 to the third is 248 minus 2, which is 6. So f of 4 is 60 minus f of 2 is 6. So 60 minus 6 is 54 over 2, just 27. Okay, so that was example 3. Let's move on to example 4. So example 4, same direction, to calculate the average rate of change from the intervals 7 to 14, where g of x equals square root of x plus 2. So it's just like example 3. We'll have to use a formula. So 7 is your A, 14 is your B. So it's going to be, keep in mind this is g of x, so it's going to be g of B minus g of A all over B minus A, right? So my B is, so 7 is your A, 14 is your B, right? So my B is 14 minus A, just 7. And then 14 minus 7 is 7. And then what's the top? G of 14 minus G of 7. So let's find that because we have a G of X function, right? So G of 14 is square root of 14 plus 2, which is square root of 16, which is 4, right? Minus G of 7, so square root of 7 plus 2, which is square root of 7 plus 2 is 9, which is 3. So 4 minus 3 is 1 over 7. So yeah, the average rate of change is 1/7. And let's do a last example, example 5. So it says, example 5, same direction, calculate the average rate of change where h of x equals 1 over x and from the intervals 2 to t. So the only difference is our y value is not a number, it's like a letter. So can we still do the average rate of change if we don't have this y value? I think we can. It's just that our final answer will no longer be like an actual real number, it's going to have a letter. So Q is your A, B, T is your B, right? So it's going to be average rate of change. So it's going to be h of B minus h of A all over B minus A, right? So B is T minus 2, and then h of T minus h of A, which is h of 2. The bottom, unfortunately, T minus 2, that's the most simplified it can be. The top, it would be, we got to find h of T. So h of T is 1 over T. And then h of 2 is 1 over 2, right? Okay, so h of T is 1 over T minus h of 2 is 1 over 2. Can we leave it like this? Can we simplify it? I think, no, we can simplify this more. This is a complex fraction. This is your numerator, and then this is your denominator. So let's fix the numerator. So it's 1 over T minus 1 over 2. So remember, if you're subtracting a fraction, you need an LCE. So what would be my LCE between T and 2? Yes, you're right, 2T. So over here, we're going to multiply top and bottom by T. Here, we're going to multiply top and bottom by 2. 2 times negative T, that is just 2 minus T. And then on the bottom, it's 2T. So I guess you can the numerators will be simplified as 2 minus t all over 2t, and then divided by t minus 2. So we can just rewrite this as divided by t minus 2 over 1. Okay, cross multiply. So 1 times 2 minus t is 2 minus t. On the bottom, 2t minus t minus 2. Just write it out. Don't FOIL it out, and you'll see why. Now, do you see anything that cancels? Unfortunately not. 2 minus t is not the same thing as t minus 2. 2 minus t can also be expressed as negative t plus 2. And then on the bottom, it's 2t times t minus 2. Can we now cancel these two things? No. But what we can do is manipulate this, right? We have negative t plus 2, so it looks like we could take out negative 1. So this would be t minus 2 all over 2t times t minus 2, right? Now do you see something that cancels? Yes, I see the t minus 2. So you're left with negative 1 over 2t. And that's your final answer. Thanks. Okay, so that wraps it up for this video. The next video will be instantaneous rate. So I'm going to stop here.